Hello everyone, it's Mr. Hein. This video is to show you how I learned to memorize and understand trig and unit circle, because this is going to be very valuable as you move through calculus, similar to how understanding multiplication table just speeds things up. It's not necessary, but highly, highly recommended. So the difficult part of the problem is not the trig, but the concepts in the calculus. Now, before we start, as with all my videos, as if this were a real class, I just want you to, if you want to, if not, the power of videos, you can skip ahead, practice some breathing exercises to help learn how to clear your brain, calm the body down in case you ever get too nervous and anxious, because it happened to me once. So put your shoulders back, and there's two things you want to focus on. Number one, be aware of your thoughts, whatever you're thinking about. For me right now, it's dang, it's Monday. Tomorrow, I'm going to hold my live classes, a little nerve-wracking. And two, take those thoughts and just focus on your breath. So here we go. Be aware of whatever you're thinking about. And then, here we go. Breathe in and out. And again, keep your focus on your breath. If you find it wandering, that's okay. We're human. Just bring it back to the breath. In and out. And last time through the nose, only in and out. Good. How do you feel? Hopefully pretty good. But let's get into the trick now. So I recommend maybe taking notes, watch it a few times, and do this until you can do it yourself with paper, not watching a video. The analogy I like to refer to is a year ago, I had a leak in my house. I could watch a 5-minute video on how to fix a leak. It made perfect sense. I was like, okay, I got this. 5 minutes. This should be quick. You know how long it ended up taking me? 9 hours. Because when you do it yourself, there's just so many more components that you have to learn. So it's easy to watch something, very different to do it yourself. That's why I always say, do it yourself. So be able to make the unit circle in your head, on paper, be able to get these exact measurements by yourself, even if this video makes perfect sense. Okay? So I'm going to draw a unit circle here, make a sketch of it. It's not going to be perfect, but it will get the job done. A little bit off. Now, degrees is, we always start there, that's 0 degrees. And you always move counterclockwise when we talk about directions in trig and calculus. So then that'll be 90 degrees, 180 degrees, 270, and you get back to your original starting position, which is 360. All right. But the goal of this video is radians, because in calculus, unless stated, you're in radians. You're in radians. So check your calculators too if you do that. Now, a radian is the length of the radius, in case you didn't pick that up or haven't learned that. So we start at 0 still. And then this right here, when you get to the 90 degrees, is actually pi over 2 radians, which, by the way, if you convert that, that's roughly, 1 point, because pi is 3.14, so that's roughly 1.07 radians, which means that if I was to pick up this radius and place it on the circumference of the circle, well, that length will get me to about here. That's 1 radius. And then when I get to that point, I actually traveled a distance of 1.07 of the radius. Radii, I think, is the proper term for when they're plural. So that's pi over 2. This, a half circle, is pi, which is 3.14 radians. So every circle you draw, the radius, pi amount, I don't want to say 3.14 because that's not really exact, but pi amount of that length will always get you a half circle. So you have pi over 2, pi, this is 3 pi over 2 radians, and when you get back, that's 2 pi. All right, and that's what the whole circle is. Now, when it comes to understanding the unit circle, there's really 2 ways to break it down. There's 2 ways, put 2 in parentheses, to break down. And that's the pi over 6 and the pi over 4. And the 6 become the pi over 3's too. So in a unit circle, in every quadrant we can break up into 3 components. There's one here, one in the very middle, and then one a little bit higher. So there's these 3 in every quadrant. Right? I'm going to emphasize that. Draw my 3 here. Don't get too lost. We'll be okay. Now the one in the middle, that triangle that it makes if you were to make a triangle with the x-axis, that is your pi fourths, which is the second way. And I'll highlight this in red for you. I don't even know if you'll see the red. All right. Now notice what's nice is once you know pi fourths, you just count your way around the circle, where every 45 degrees of pi fourths is 1. So that's 1 pi fourth. And if you went that same distance, technically when you get here, you're at 2 pi fourths when you're at this point right here. But what is 2 pi fourths simplified? Well, if you divide both by 2, you get pi halves. Go another in the middle when you get there, if you're just counting, that right there is now 3 pi fourths. And then you go again, and then you're at 4 pi fourths, which notice 4 over 4 just simplifies to 1 pi. And then you keep going, and then you're at the middle there, which is 5 pi fourths. You go another 45 degrees, and then you're at the bottom, which is now 6 pi fourths. But notice when you simplify 6 pi fourths, divide each of these by 2, you get 3 pi over 2. You go again in the middle, and you're at, should I pick the middle line that I drew here? It's a little bit sloppy, but that's okay. Math is more about the idea, the organization in the beginning stages. But then you're at 7 pi fourths, and then you go again, and you're at 8 pi fourths. And what's 8 pi fourths simplified? 8 divided by 4 is 2 pi. So notice that if you just go by pi fourths, you hit all the middles, the middle and the x and y axes. All right, so when I say break down, if you count by these and then simplify, and that gets you your whole circle. So that's pi fourths, which is one way of going about the circle. And then the other way is all the other ones, which I'll try to highlight using a highlighter. And that is going by pi sixths. So that first one is pi sixths, which is 30 degrees, by the way. I'll just emphasize that, because these are the 30, 60, 90 triangles, which I'm going to get into later in this video, and that's the 45, 45, 45, 45, 45, 90 triangles. So you have pi 6. Now, if you count, the next time you do that amount, you're going to be actually up here, which is 2 pi 6. But what's 2 pi 6 simplified? That's actually pi thirds. And that's where the pi thirds comes from. That's why I really say there's two ways, even though there's another measurement going on. So you have pi 6, 2 pi 6, or pi thirds. Up at the top, you'd be at 3 pi 6. But what's 3 over 6 simplified to? 1 over 2, which is the pi over 2. Then you come here, which is 4 pi 6, if I keep counting. But simplified, that's actually 2 pi thirds, is the better answer there. And I know this is getting messy. That's why you're going to have to redo it. Redo this, make maybe 2 circles, one with the pi fourths, one with the pi 6 and pi thirds, so you can differentiate the two. But anyway, so you have pi 6, 2 pi 6, 3 pi 6, 4 pi 6. The next one's going to be 5 pi 6. You go the same amount. You always hit the axes on either way you count. So then you're at 6 pi 6, which notice 6 divided by 6 is 1 pi. Then you'd be at 7 pi 6, and I'm just going to highlight all these right away to save myself some time. So then you'd be at 7 pi 6, 8 pi 6, which if you simplify 8 over 6, divide by 2 to both those, you get 4 pi thirds. which again is another third. Then we'd be at 9 pi 6 down at 270 degrees, which divide by 3, you get 3 pi over 2 again, right? That main answer. Then you'd be at 10 pi 6, which simplify that, and then you get 5 pi thirds. 11 pi 6, 11 pi 6 is right here. And then you get back to the beginning, which is 12 pi over 6, which divided by 2 is 2. So there's really only 2 ways to count around it. It's pi 6, where you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi 6, which gets you back to 2 pi. And then you can simplify it to get your thirds. And then there's fourths in red, which goes 1 pi fourth, 2, 3, 4, 5, 6, 7, 8 pi fourths, which gets you back to 2 pi. Right? So there's really 2 systems going on in the unit circle. The 45, 45, 90s, which are the pi fourths, the middles. And then there's the 30, 60, 90s, which are also happening. Now, it does come in handy to know that your thirds, if you see where all your thirds are, as you help try to memorize this picture in your head, visualize this. Notice that all your thirds are closer to the y-axis. So just another thing to think about in your head, is I'm going to show you how do I get the exact measurements in a second, how I memorize it. So the thirds are close to the y-axis. Okay. Now, there's our unit circle. Now, how do we know exact measurements? What I mean by that is, and I'll push this up a little bit. If I ask you what's cosine of pi 6, you need to very quickly say that the answer is square root of 3 over 2. If I was to say what's sine of 7 pi 6, you would have to quickly just give me the answer of -1/2. And that's what I mean by you want to get quicker at these so you don't get caught up in this part of the problem or make mistakes at this when we get here in calculus. Now, how do you get these answers quickly? Right? So if we come back to the unit circle, these are all coordinates. Right? Now, if you look at the pi 6 and pi thirds, break this down here, the pi 6 slash pi thirds, they make 30, 60, 90 triangles. Okay. So if I was to make a triangle right here, you have your 30 degrees and your 90 degrees and your 60. And this is a unit circle, so the radius is always 1, right? The radius anywhere along the circle is 1 because it's a unit circle. Now, on a 30, 60, 90 triangle, if the radius is 1, the shortest side is always half of that, so that would be 1/2. And then the adjacent side of that would be square root 3 over 2, because it's square root of 3 times this. And a more advanced topic, but it does come in handy, advanced, is that when you talk about 30, 60, 90 triangles, the ratio is really 1 to root 3, where the smallest side's opposite there is whatever length it is, the hypotenuse is double that, and the adjacent side opposite of 6 degrees is times by square root of 3. So it's times 2 times square root of 3, and it kind of is consecutive into 1, 2, 3 plus square root of 7. So how does this come into play? Now, what you need to remember too, and this is a lot because I'm covering weeks of material in one little video, is cosine is your left and right. That represents the x coordinate. Okay. And then sine is your vertical, which represents the y coordinate. So the way I remember this is if I know it's a sixth or third, if I know it's any of these parts on the circle, I know the measurements are either going to be 1/2 or square root of 3 over 2. The question is, which one is it? Well, which one's bigger? Is 1/2 or square root of 3 2 bigger? 1/2 square root of 3. Now, understanding fractions, if they have the same denominator, you're like, which one's bigger? And sometimes we get confused. And if you're not sure, change the number. Make this like, 100 over 2. What's bigger, 1 over 2 or 100 over 2? Well, 100 over 2 is 50. So that must mean if the numerator is bigger, that makes it a bigger fraction. And square root of 3 is bigger than 1. The square root of 3 is about 1.5. So this is the bigger number. And I'm going to tell you in calculus, and the way I'm going to approach this is you really want to understand numbers. Oh, sorry. So that's the bigger number, which in turn, if that's the bigger number, it also means that it's the longer side. Now, how does that come into play in the unit circle? Is if I say pi 6, and I was to make a little triangle here, well, what's longer, the x that I have to travel to get to that point, or the y that I have to travel? Well, clearly you can see in your head that the vertical distance is shorter. So the shorter side, if I make this a coordinate, is the 1/2 because it's smaller. And the x coordinate is the square root of 3 over 2, right? The xy is I had to travel more x than I did y, and there's your coordinates of pi 6. So then if I said what's cosine of pi 6, like I did here, then I'm looking at the x value of that coordinate. So the x value of pi 6 is square root of 3 over 2. Sorry, it's getting a little bit messy. And that travels anywhere up it, right? So 2 pi 6 is the shorter now is the left and right. So then that means that the x is the 1/2 and the y is the square root of 3 over 2. If I was to come to 5 pi 6, what changes is not much, just the positives and negatives. The left and right, the x is longer, so I know that that's the square root of 3 over 2, and the y is the 1/2, but since I had to travel left, that makes that negative, and the y value is positive because you're going up still. Because don't forget about, you're on a graph where it's positive, negative, in the direction that you're heading. Right. So if I was to make a quick unit circle to show you that down here, here's a little preview. This is just a small one. Pretty good. All right, here's your coordinate 0, 0. This first one, the x is longer, so that's square root 3 over 2, comma 1/2. When I come up here at the pi thirds, remember, pi thirds, or 2 pi 6 if you're counting, the x is shorter, so then that's 1/2 square root 3 over 2. It's a unit circle, so that's 0, 1, where the lat length is 1. If I get to that, the shorter is still left and right, so that's the 1/2. The y is square root 3 over 2. X is negative, because I went left first. If I come over here, now I'm traveling longer left and right, so that's square root 3 over 2, up 1/2. Here would be the point negative 1, 0. If I come over here, I'm still traveling really far left and right, so then that's the square root 3 over 2, and then I'm going down the short amount 1/2. But since I went left and down, they're both negative. This one down here would be negative 1/2 negative square root 3 over 2. Here's 0, negative 1. And hopefully you're catching on to how I just more or less memorized 1/2 of the unit circle. 1/2 negative square root 3 over 2. And the last one would be square root 3 over 2, comma negative 1/2. So don't look for patterns within it. That might help you, but let's understand how a circle works in those lengths. These are all lengths. You have to travel a length left and right and a length up and down to get to that point, one of them being longer than the other. And there's your pi 6 and pi thirds unit circle. Or again, if I wanted cosine of 5 pi 6, 1, 2, 3, 4, 5, cosine's the x, so cosine of 5 pi 6 is negative square root of 3 over 2, right? 1, 2, 3, 4, 5, it's the x, there's my answer. Or in my head, I might just picture that I'm located here, which at this point I have to travel more left and right, so the x, which is the cosine, is going to be the larger of the fractions. So there's your 30, 60, 90 triangles of pi 6 and pi thirds. And this is messy. I hope yours is a little bit more. I'm just keeping it on one page because I'm a little lazy. And then let's look at your pi fourths, which are your 45, 45, 90 triangles, which on a unit circle, the measurements break down as follows. Would be, that's 1 because unit circle, it's going to be square root 2 over 2, square root 2 over 2. Right, 45, 45, that's isosceles triangles where these are the same length since they're opposite of the same angle measures. Okay. Now with these, notice that these are the same. So this part of the triangle is really easy. This part of the unit circle. The circles are getting worse as this video goes on. All right, pi-fourths are all the middles. But that first one is the coordinates are always square root 2 over 2, square root 2 over 2. Because it's in the very middle, it's an isosceles triangle, 45, 45, 90. And then all you really focus on is the positive negatives, is really all you focus on with these. That's still 0, 1. This one now, again, it's still the coordinate square root 2 over 2, square root 2 over 2. But I had to go left first, so the x is negative. The second one's positive. This one down here at, that's 4 pi-fourths, so that's 5 pi-fourths. So see how I did that there if you're watching this? That I know that that's 4 pi-fourths because that's 1 pi. That's like an anchor measurement. So then I can just count from there, and that's 5 pi-fourths. That'll be negative square root of 2, negative square root of 2, because they're both, you go left and down. And over here, you would be at positive square root of 2 over 2, negative square root of 2 over 2, right and down, at the 7 pi-fourths. Okay. So then if someone ever said, I'm squeezing it in here, I'm getting crazy. If I do cosine of 3 pi-fourths, I count in my head 1, 2, 3, so I'm right here. Cosine's the x, so then I went left first. So that's negative square root of 2 over 2. If I wanted sine of 7 pi-fourths, if I count, well, that's 6. Or you can count 1, 2, 3, 4, 5, 6, 7. Sine's the y value, which is then also negative square root of 2 over 2. And that right there is how you can start to get these answers very quickly, because in your head, you're better understanding all these measurements. Now, spend some time on this. The goal is that you should be able to recreate the unit circle with all the measurements with just a blank piece of paper and a pencil with nothing around you, because you can all figure it out in your head. That's the goal. Keep working at it. Some of you are going to get quicker than others, and that's natural. That doesn't mean anything. But that's a goal that you want to head towards. If you have more questions, or if you want to ask me anything, stop by office hours. If you have other ideas, I'm more than happy to listen to them, because this is just one way. I know Miss Palmer and other teachers have their other ways too. All right. Good luck.